last time we were graphing systems of inequalities, and what a graph of here's an inequality. 2x plus y is greater than or equal to 5. Negative x minus 5y is less than or equal to negative 10. To graph it, we get it in y equals mx plus b form. You already know this. It's what we learned last time. I'm just going to make a connection here of what we're doing today. So look, I've rewritten it in y equals form for this. And for this, I've rewritten it in y equals form. So I graphed both those lines, and then I shaded. Does everybody see? So y value is greater than, y value is greater than. So I shaded. So this graph represents all of the solutions. All the shading are the solutions. So we talked about how there are a bunch of x, y points here, right? As solutions. So what we're going to be doing today is instead of a system of inequalities, we're going to be doing a system of equations. So instead of an inequality, there's going to be an equal sign here. So it actually works almost the exact same way. Notice I got it in y equals mx plus b form, and then I graph it. It's just this one doesn't have shading, so there's only one solution. It's only where they intersect, only where they're equal. Does everybody see? This one had a lot because it's y value is equal to or greater than. So we had to shade. We have a lot of solutions. Where right here it's just saying where they're equal, which is where they intersect. Do you guys see? So like they only intersect at an x, y point. So we write our answers as that one specific x, y point. We're actually going to do this not very often by graphing. We're going to be using algebra, so we'll talk about that. So here are the different types of solutions you will see with something like this. So if we have two lines that intersect in one spot, that's obviously the only solution. That's the one solution, and it will be an x, y point. Now if you end up having parallel lines, if they have the same slope, they have parallel lines, they're never going to intersect. So they will never be equal. So this one would be no solution. So if we were solving and our variables canceled out and we got something like this, 2 equals 3, that's not true, correct? We've seen stuff like this before. So we would say, oh, that's not true. Our variable went away, so we couldn't solve for x or whatever, or for y. Therefore, there is no solution. So if there's no solution, you can write no solution. You can put that little sign for no solution, and you'd be done. Now here's the thing, guys, if you end up with a line and then another line right directly on top of it, so this isn't actually one line, there's two lines here, they're just one right on top of another. There's an infinite amount of solutions here. Do you see why? This line goes on forever. You guys see how there's a lot of xy points. There's an xy point. There's an xy point. There's an xy point. There's a ton of xy points here that are all solutions. So we have an infinite amount of solutions. It's just the solution is that specific line. Any xy point that falls on that specific line. Does everybody see how that would make sense? So we actually write this answer a little different. So let's say you're solving and you get your variables cancel out and you get a true statement. Like 3 equals 3. Yes, that's true. Our variables went away, so we couldn't solve, but we technically could. We would have to remember, oh yeah, this would mean that there are an infinite number of solutions. Now we can't write all real numbers because it's specific. The solutions are what fall on the line. So we actually write out, the line that it is. Like that's the solution, the line. So y equals mx plus b. We would write whatever the line is, because that is our solution. Does that make sense, kind of? Or you can write it in standard form. This is point slope form. So remember standard form, and that's actually how our book is going to write it, is ax plus by equals some constant. This and this are the same thing. They're equal. I won't mark one or the other wrong. So you can write it however you want. Okay, let's start practicing. So just watch, because you're really good at graphing at this point. If I said solve by graphing, you would get it in y equals mx plus b form. So guys, let's subtract x over true. So we would have y is equal to negative x minus 1. Now over here, we'd solve for y, so we'd add 2x over. So then we would have y is equal to positive 2x minus 7. So let's graph this. So just watching. So negative 1's our y-intercept. Our slope's down 1 over 1. So let's see if I can get that going here. So I'm just going to graph it the best and as accurate as possible. Then right here, so that got off a little bit. Okay, let's graph this one. So we're at negative 7, and then our slope's up 2 over 1. So up 2 over 1. Up 2 over 1. Oh, there's our solution. Up 2 over 1. Up 2 over 1. I don't need to keep going because I can see the solution. It's where they are intersecting. So our answer literally here, our xy point is over 2 down 3. So they actually I write it like this. My xy point is equal to 2 comma negative 3. So you remember the format you put it in. So yeah, not bad, right? Solving by graphing. Now here's the thing. We're not going to really solve by graphing all that often. We're going to end up solving with algebra. But let's say I give you this one. I'm asking you, are these following points a solution to the system of equations? What do you think, based on what we've done before, what would we do? Plug it in and see if it's a true statement. So we plug in 3. That's 2 times 3 plus 3 times 1 equals 7. And at the same time, it has to be 3 times 3 plus 1 equals negative 7. If it works in both, it's a solution. If not, it's not. Does everybody see? If it works in one and not the other, it's not a solution. Do I need to keep going? Do I need to calculate it, or you get the picture? Okay, I don't want to waste your time. I'd rather give you homework time. So you plug it in, and if it is, it is. If not, you say no. Okay, it's got to work in both. Okay, so here's what we're going to do. We're going to be using algebra to solve these. We have to be so good at this algebra. You don't want to make errors because once we start doing the huge ones next time, you can't figure out where you made the error. You have to just redo the problem. So we got to be really careful because you don't want to make errors. So here are the two methods we have to solve, substitution and elimination. We've learned this before, it's just been a long time. So I'm going to show you how to solve by both methods. I will specifically say solve by substitution or solve by elimination, but then I will give you a section that says solve by the method of your choice. So it is really wise to know when to use what. So I'll explain. Okay, so here's substitution. Look, notice it's solving the same equation. We're just going to do it 2 different ways. So solving by substitution, what you're going to do is you're substituting in a variable. So what you're going to do is you're going to get one of the variables, either x or y, right here, or x or y down here. You're going to get one of those alone, meaning you want it to be x equals or y equals. So here, let's think smartly here. You're going to want to solve for the variable that when you solve for it, there's not going to be fractions. So look, if I see how y is all by itself, there's nothing multiplied in front. I'm not going to have to divide out anything, am I? So there's not going to be fractions. So I would wisely choose to solve for y on the top. Because look, down here, if I solve for y, I'd add 2x, and then I'd have to divide by 3. And now I'd be substituting in fractions, which would work, but it'd be harder. So you'd say, okay, I always write myself little notes to help me not make errors when we start doing harder ones in the future. So I take this and say, okay, I'm taking the top one, and I'm going to solve for y. So that means get y alone. So that would be subtract 3x, subtract 3x. So now we have, I'm going to write it below this, y is equal to negative 3x minus 9. Is everybody good? Now what you're going to do is you're going to take and you're going to substitute that in to the other equation wherever there's a y. So look, if y is equal to this, we're going to take it and plug it in to the other equation wherever there's a y. Now look why that's going to be useful. If we take and substitute that in for y, do you see how there's only x's now in our equation? And then that would be nice, because when we have only x's, we can combine them and solve for x. So let's rewrite this. We have negative 2x plus 3, and when you're substituting something in, you got to use parentheses. So we're replacing that y with this, negative 3x minus 9, and that's equal to 17. Does everybody see where I made the substitution? Now look, only x's, that's great. Now we can solve for x. So here we go. We have negative 2x. We would then distribute in 3, so minus 9x looks like minus 27. That's equal to 17. So now combine like terms on this side. So I have negative 11x's minus 27 equals 17. So now solve for x. So we add 27. Negative 11x equals, if you add 27, over here you get 44. So now you say, okay, I'm almost there. Got to divide by negative 11. So x is equal to negative 4. Okay, I circle it, but I can't stop there. Because I know my final answer is some xy point. We know our x value is negative 4. Now we need to figure out our y value. Now think about it, guys. If I graph a line, and I graph another line, if at x equals negative 4 they intersect, isn't their y value, it doesn't matter where I plug it in. If I plug in negative 4 on the top or bottom, will the y value be the same? Because that's where they intersect. Like, look back here. At x equals 2, didn't they have the exact same y value? Do you guys see? So if I plug in 2 to the top or bottom, we're going to get out the same y. Do you guys see? So, right here, it doesn't matter which one you plug it into. So I'm going to just randomly go with, okay, I'm going to plug in negative 4 into the top one. So I'm going to make a little bulletin point. My work's getting messy here. So we have 3 times x. X is negative 4. Then plus y equals negative 9. Solve for y. So negative 12 plus y equals negative 9. So add 12. So y is equal to 3. So we are done. There's our xy solution. Not too shabby, right? Substitution. Okay, that's one way of doing it. Now there's a process called elimination. So it's the same problem, different way of doing it. But seeing them side by side might help you decide which one you like better and for what reason. So looking at this one, with elimination, what you're doing is you're going to choose a variable altogether to eliminate. You're either going to eliminate y or x, and it does not matter. So guys, to eliminate it, what's going to end up happening is we want to have it so that if we were to combine these, squish them together, add straight down, one of the variables will be gone. It'll add up to be 0. So in order for that to happen, they have to be opposites, exact opposites, like 2x and negative 2x, because if you add those up, you get 0. Does everybody see? So you could choose, I need to make my x's look the exact same but opposites, or I need to make my y's look the exact same but opposites. So, in this problem, wouldn't y be easier to make opposite? Because with 3 and 2, how would we make them the same? It'd have to be 6. Does everybody see? Or right here, can't I make them 3? Okay, so you'd say, oh, this is positive, so I write myself, I'm eliminating y. So I need them to be opposites. This one's positive 3y, so won't this one need to be negative 3y? Now you can't just write a negative 3y or you change the problem. However, if you take and multiply that whole equation by negative 3, it's okay, as long as you do it to the whole equation. So let's rewrite our new equation right here. Negative 3 times 3x is now negative 9x's, everyone. Negative 3 times positive y is negative 3y's. Negative 3 times negative 9 is positive 27. And now when you add straight down, if one of your variables doesn't cancel out, you've just done something wrong. So let's add straight down. Negative 2x plus negative 9x is negative 11x's. True? This plus this is 0, so we know we've canceled it out correctly. That's equal to 17 plus 27 is 44. Now solve for x, so divide by negative 11. So x is equal to negative 4. Look, that's what we got here as well. So we'd say, okay, so we have an xy point. We know the x value is negative 4, so now I need to plug it into one of the y values, just like we did over here. Now this process is no different. Plug it back in. So we already did that. We plugged it in up in the top, and we got 3. You take and plug it in wherever you want. Okay? Let's practice some of each type of method. So here we go. So let's do 2 with substitution, then I'm going to let you practice some on your own. So it says solve using substitution. Now why would they tell us to use substitution in something with this instance? Look at the top. Isn't it already y equals? This one's easy. It's telling you y equals negative 3x minus 5. So it would be very obvious to use substitution here, because now look, we can take this and plug it into the other. It has to be the other equation. You can't plug something back into itself, just saying. So we're going to plug it into the other equation wherever there's a y. So rewrite it. So now instead of this, we actually have 5x plus 3. Y is gone. We now have that. Substitute it in instead. Negative 3x minus 5. That's equal to 1. Now look, all x's. If you still have y's, you've done something wrong. That was the point of substitution, to only have one variable. So now let's multiply that out. Ding, ding. So 5x minus 9x, true? Minus 15 equals 1. Combine like terms. So I add up this side what I can. Looks to me like that's going to be negative 4x minus 15 equals 1. Now look, solve for x. So we add 15. Negative 4x is equal to 16. Therefore, x is equal to negative 4. Great. I'm going to circle it, but I know that that's not my final answer, because I got to write it as an xy point. So I'll write my final answer right here. I have an xy point equal to, my x value is negative 4, but now I need to figure out the y value. So here we go. Plug it into the top or bottom. It doesn't matter where. You'll get the same answer. So I'm going to take this I'm randomly choosing to, well, I'm not randomly, I'm putting it in the top because it's already y equals form. But it would not matter. So we would have y is equal to negative 3, our x is negative 4, minus 5. So y is equal to negative 12 minus 5, right? Oh, no wonder. Positive 12 minus 5, so y is equal to 7. Boom. We're done. Not too bad, right? Okay. One more, then I'm going to have you practice. So, in this one, which variable would you solve for? Y in the top or bottom? The top, because it's like there's no fractions we have to divide out. So we're going to use the top, and we're going to solve for y. So get y alone. Subtract 2x, and rewrite it. So we're having y is equal to negative 2x minus 2. And now we can take and substitute that into the other equation wherever there's a y. So that's going to go right there. Negative 3x minus 2 times by negative 2x minus 2, replacing that y, equals negative 2. So we have negative 3x. Distributing negative 2. You don't want to make errors here. So it looks like it's going to be plus 4x's. Plus 4 equals negative 2. Add up like things. So that's going to be x plus 4 equals 2. Therefore, x equals, subtract 4, and you get negative 2. X, y equals, oh, is it negative? It is, oh, I didn't write down negative 2, did I? So good catch, because that would have been wrong. Good point. Subtract 4, so it should be negative 6. Good catch. So negative 6, comma, we don't know. Now let's find out. Plug in negative 6 in for x, either top or bottom. So I'm going with the top again, just because I'm going to make a bulletin point so I can keep my work a little bit pretty. 2 times negative 6 plus y equals negative 2. So negative 12 plus y equals negative 2. Add 12. So y is equal to plus 12, right? 10. Now guys, let's say you were desperate and on the test and you're like, did I do that right? You could graph it and look with your eyeballs if that's where they intersect. Does that make sense? You show your work this way because I'm telling you to use substitution, but then let's say I gave you scratch paper, you could do that on graphing paper. Okay, practice a few of those before we practice more with the elimination. So watching, if you don't need to take notes, that's fine, just watch. So which variable do you think we should cancel out? Y or x? Y. Okay, good. So what would I multiply by? The top by? Yep, good too, because this one's already negative. Good. So distribute, distribute, distribute. I write it underneath. So that would be 10x plus 4y. True? Equals negative 10. Add straight down. Things should cancel out. So we have 8x. That's gone. Is equal to negative 24. Therefore, x is equal to negative 3, I think. Right? Okay, x, y. Negative 3, comma, let's hurry and plug it in. So, right here, 5 times negative 3 plus 2y equals negative 5. Negative 15 plus 2y equals negative 5. Add 15, what do I get? 10 divided by 2 is 5. Okay, awesome. Next one. Which variable? Y, what would you multiply by? Negative 3, because this is positive. Distribute, distribute, distribute. Once again, so 6x minus 3y equals negative 12. You'd add straight down, so don't we get x equals negative 4? Yeah, negative 5. xy, we get the picture here. Negative 5, comma, plugging it in. Negative 2 times negative 5 is negative 10, right? Oh, I'm struggling. 10, and then subtracting 10, you get negative 6. Okay, I swear one of these has no solution. I mean, I know I put one in, so that's why I've been trying to get there. Okay, look at this one. Elimination. It would still be better than substitution. Here's why. Because no matter what, we're going to have fractions if we use substitution. Do you see? So we'll have to divide by 4, or negative 3, or 2, or negative 3, and nothing will just all cancel out. So elimination's still best. Now, honestly, these are equally easy to get rid of, x and y. So here's the thing. Pick one. Y again? Okay, so we need to make them the same. The only thing that could be the same is making them 6. Does everybody see why? This one has a 2, this one has a 2 and a 3. Okay, so you need to make this 6, so times by 3. You need to make this one a 6, so you multiply by 2. And in fact, you want it negative 6, my bad. So distribute, distribute, distribute. To distribute, distribute, distribute. Is everybody good with that? Do I need to keep going? Okay. This one's still going to have a solution. I want the ones with no solution. Okay, it says solve by your method of choice. What method would you choose in this one? Elimination. And wouldn't you multiply this one by 2 to get rid of y? I can't remember. Let's see. Is this one that has... I think this one...
Yes, because it will become 6 and it will also become.
Awesome. So let's keep going with this one so you can once again see it. So then we have 6x plus 4y equals 4. So we add straight down, and that's 0 plus 0 equals 8, 9, 10, 11, 12. 12. Does 0 equal 12? No. So when there's no solution, there is no solution. Like, you can't, there is no x value, so there's no y value. So no solution. Now what happens if we were to get like a true statement? Once again, what would we write? So right here, this is a good one to do. This is the one. So you'd say, I'm going to solve with elimination. I'm going to. Personally, I like it better. Do you agree? So I'm going to multiply by 2. So multiply, multiply, multiply. So then we would have 6x plus 2y equals 3 equals 2, right? Sorry. It's a little awkward there. I'm like thinking ahead. Okay, so add straight down. So that becomes 0 plus 0 equals 0. Does 0 equal 0? Yes, so here's what, you can't just say all real numbers. That's not how this works. If the solutions are anything that falls on this line, correct? Guys, if your answer comes out to be all, like any x value we can plug in, then these are the same thing. Look, if you were to simplify this, if you were to get it in y equals mx plus b form, it would simplify the same. Does everybody see how it's actually the same line? So our solution is, so we have x, y points that fall on the line. So they actually write it like this. So they do parentheses, they write the equation of the line. You can do the top or bottom. We're gonna always kind of want to do the more simplified one. You see how this one's more simplified because things are divided out? You can put it in standard form, which is this, or y equals mx plus b form. I'm always going to write my answers because the book does, which they're equally good, so I won't mark it wrong on the test. I'm just going to put it in standard form, which is the x, the y, then the constant. So I'm going to say 3x plus y equals 1. Because it's the solutions that are these x, y points on this line. Does that make sense? Sweet. Then I think you're good. Okay, that's the end of 4-1. The rest of the time is yours. Get as much done in class